Hi everyone, today I'm gonna practice a coding interview about LeetCode 1658, minimum operations to reduce x to 0. The question is, you are giving an integer array nums and an integer x. In one operation, you can either remove the leftmost or the rightmost element from the array nums and subtract its value from x. Also pay attention that this modifies the array for future operations. The goal is returning the minimum number of operations to reduce x to exactly 0 if it is possible. Otherwise, return -1. So when I first take these questions, I will think about using the dynamic programming, the DP. So as you can see here, since the number are always taken from both ends of this array, we can use a two-dimensional array. The first dimension stores the numbers from the left, and the second dimension stores the number from the right. When the sum of the number from the left and right equals to x, return the indices of the array. That is how I thought, and I practiced that using this snippet of code, and it turns out it could pass portion of the test cases, but I would say it's kind of intricacies that dealing with this two-dimension array, and since the type complexity will be here is n squared, and the space complexity is n squared as well. So unfortunately, it will fail at the end and said it's exceeded the memory limit. So let's think about another way. So now read the questions twice. We can tell that the minimum operation to reduce the x to 0, which also equals to find out the longest subarray of this array. The longest subarray of this array that has the value equals to the total sum minus the fragment sum. So let's think about this way. We want a longest subarray. Which the max equals to the longest fragment sum equals to the total sum minus x, and which is the total sum. Let's try it again. Now first we go through all the array's elements. And do our calculations. Total sum equals to 0, and total sum, and okay, great. for we need two pointers, which is left and right. From there, we keep the boundaries of the subarray and have a check, which means first we will let the right pointers goes in and calculate as much as it could. From there, that portion go from 0 to right pointers is the fragment sum. When this fragment sum equals to the total sum minus x, then its length is exactly what we want. And if it goes up, it goes down, we need to adjust it by letting the left pointers in. And that's how it goes. While R let's try. Fragment sum equals to 0. And if fragment sum and also we need to keep an eye on that. If the fragment sum is bigger than the total sum abstract x, we need to adjust it dynamically. So while the fragment sum is bigger than total sum minus x, we need to let the left pointers in. And also the left pointers will move one step forward, minus nums. Okay, then if the fragment sum equals to total sum minus, that's where we need to set the check that do the checks if the length between the left and right is the max. Okay, now we set it to we need the results. Let's do -1 for now. We want to keep the max value. Okay. Okay, and we think that is what we want. In return, pay attention that we want the minimum operations, which is the opposite of the max result. Don't forget about that. Oh, my bad. I'm a bit nervous. Plus oh no, oh what I'm doing. Okay, let's try. Index 2 out of the bounds. Okay, I think I got I need to pay more attention to the details, so we need to also ensure that the left won't exceed its limit. Okay, so the time complexity is n, and the space complexity will be constant. Yes. Yes, and thanks for watching.